Okay, so today's Wednesday, second week of the DeCal. Welcome everybody. Thank you for coming. A little quick announcement, or I guess I'll just start with announcements. First, fill in the attendance form, please, and then like the office hour poll. We're going to decide office hours tonight. So if you don't fill it out now, you're not going to have a say in when office hours are. But we'll have lots of office hours. There's 5 of us teaching, so I'm sure we'll be able to accommodate you however you need. But yeah, make sure you fill these out if you want a say in it. And then don't forget your attendance form because it is part of your grade. We had a few people not do their attendance last week, but make sure you do it. Okay, recap. So we're gonna talk a little bit about what we did on Monday. We did basic command line, a couple commands. We didn't really go too deep into it, but Elon did a little bit of a demo, showed you how to navigate, how to change your directory with the cd command, how to make a directory, which is the same thing as making a folder, and how to go into that directory, how to print what directory you're on, print working directory or PWD, and how to show what's inside of a directory, ls. I don't really know what ls stands for though. So, but those are the 4 commands, and we talked about that a little bit. He went into data types very deeply. He showed all, I think, 8 of them or something like that. Can you name them all? Well, they'll be part of breakout rooms if you want to. And then today we're going to cover functions. So we didn't really cover it on Monday. We didn't get to that. But today we're going to cover functions. And that's like kind of the cornerstone of programming is functional programming. And we'll see some examples of what that means. So yeah, before we get started, it's breakout room time. Something we like to do is make sure that you retain at least some bit of knowledge from last week or last time we met on Monday. So what we're going to do, we have 2 challenges for you, and we're going to make 2 breakout rooms since there's like only so many people in the DeCal anyway. The first challenge is tell me what does cd, mkdir, or mkdir, pwd, and ls all mean? How do you use them? I kind of just said that, but say it amongst yourselves. And then the real challenge is this problem right here, saying if I pwd or pwd, and the terminal reads users your name desktop. Okay, so you're in the desktop directory. How would I get to a new directory? Say the PyDecal directory from that, if there is no pre-existing folders on the desktop. So with that question in mind, I am going to go ahead and make breakout rooms, make 2 breakout rooms for everybody. Instructors don't go in them unless you want to, but yeah, so if I was a breakout room, I would be here. That's where I would be. 2 breakout rooms, and then there we go. Okay. So we're gonna do this for about 5 minutes, and then we'll all come back. And also get to know each other. Say hi, hello. This is like, Zoom sucks to meet people, but try your best to meet somebody to do your homework with, maybe, because I promise you the homework will get difficult. It's not going to be super easy. The first one's not that bad, but it does get a lot more difficult. So you're going to want somebody or a couple people to work with in the future. So say hi to everybody and introduce yourselves again and stuff. Here you go. 5 minutes. Share the screen again. Okay, is everybody back? Not quite. Oh, cool. Thanks, Rav. Or Rob. I'm terrible.
Yeah, no problem.
Is it pronounced
Rav.
Rob or Rav?
Rav.
Rav, okay. Thank you for making a Discord. That's actually awesome. Then in that case, we won't even make a Piazza. Then I think it'd probably just be best if we just keep the class Discord.
Someone else made a Discord?
Yeah, Rab did. It's in the chat.
Oh, I also made one. Cool.
Oh, okay.
Oh, oops.
Fight to the death. No. Well, how about whoever made the Discord, just email me and we'll set it up so that everybody can access. I'll put it on the course website so it's easy to attend. Cool. All right. So I think everybody's back. I hope that was somewhat helpful or useful. Does anybody want to volunteer to answer? I don't think we like. I think we could just do challenge 2. Does anybody want to take a volunteer to answer challenge 2 for me? Anybody, please. Challenge 1. Big sad. Okay. If nobody wants to answer, then I guess the way you would do challenge 2 is so if you're on the desktop directory, that's the equivalent of just being like on the home screen, but in the terminal. So you need and there is no folders on your directory on your desktop, so you need to make a folder in order to change into that folder, go inside of it. So you need to mkdir or make directory, and then you call it PyDecal, and that'll make a PyDecal folder, and then you can cd inside of the PyDecal folder. So cd PyDecal. And that would put you inside of the PyDecal folder, which is just a branch off of your desktop. We're kind of like going further into the tree of folders or like branches that you can go into. So that is that. Is there any questions about that? Okay, I don't think so. So in that case, let's actually get into today's lesson. So we're going to talk about functions, the introduction to functions. Basics are well, like let's just look at how you define a function, your own function, and kind of break it down, analyze it. So can everybody, is there like a way to do like a laser pointer? Aha. So in order to make your own function, you have to have what's called a def statement, which is short for define. It's defining your function, what it's going to be called. So def and then the name func. So this blue word right here is the name of your function. So this could be anything. This could be radius, or this could be like volume. This could be area. This could be my special function underscore. I love it so much. Doesn't matter. But this is your name. You always have to have a name, and then parentheses, and then what goes inside the parentheses. Those are your arguments. So those can be 1 variable, 2 variable, 3 variables, however many you want. We call those arguments in computer science, but they're the same as like a normal math function. They're like your input variable. And then inside of your, also you can't forget, you also have to have a colon. Those are super important. If you don't have your colon, then your function won't work. It's just syntax though. And then you tab inside of it. So you enter and then tab. So pay attention to the space. You definitely need a tab, not a space, but a tab over, or else Python will scream at you. It's just syntax again. But then you have your body of your function. So we have our name, or our defining statement with our name at the top, or the head of the function. I call this the head right here. And then this middle part is your body of the function. So here I define a variable, we call it y. We talked about variables on Monday. And we say y is equal to x to the 100th power plus 23 times x squared plus 56. These are all expressions, right? Mathematical operators. We have to the power of, multiplication, addition, and basically what this spells out is a polynomial, right? And then once we have this variable inside of our function, y, we return that variable. So this is our return statement. So we have our head, which is the defining statement. We have the defining part of the function. We have the body, which is all the kind of calculations happen inside of your body, and then what it spits out at the end, and that's your return statement. Cool. So just like a mathematical function, f of x, it takes a value s, or it takes value or values, and it outputs some other value. Yeah, so every like big amount of space you see, that's a tab, but like these are definitely spaces here. But like this is definitely a tab, this is definitely a tab. So yeah, this is like when you're inside of a function, you have to tab over. It's like white space essentially, or black space, whatever you want to call it. Yeah, and then so another example of a type of function. Let's say I have some values and I want to convert it to a string and attach like a .jpeg at the end, JPG or JPG, JPG at the end. So it's like a file name for like a photo. If I wanted to do that, let's say I wanted to convert this list, for example, 23,7. It's just a list of numbers to me, but let's say I wanted to call a photo that image name, or like that name for the image. Well, then I could write a function that takes that input, that list, and spits it out as a string instead. I can just convert it in a function. The syntax of how you do, or like how you do that in the body, well, that's up to you to write and figure out, but just know that you could do it. You could take in any type of value, any values, or you could specify what kind of values only work for that function, and you could spit out a return value. In this case, that return value would be like a string that says this. And then there's built-in functions. Those are like pre-built in Python. They're super useful and you use them all the time. Particularly, like probably the most used built-in function I've ever used and most people use is the print function. If you ever want Python to spit like a sentence or a text at you, you use the print function. Then there's like absolute value, ABS, max, min, pretty self-explanatory. Those are like built into Python. Yeah, so I guess before we get into advanced function, I just want to mention the way you call the function, the way you use it. You write down the name of the function. So in this case, I would write down func outside of this define statement. Way down later in my code, I write func, and then parentheses, whatever number I want to plug in. So let's say I wanted to figure out what I would get if I plugged in 10 for my x value. You type func parentheses 10 parentheses, and then that'll give you the value. And you can set that equal to another variable. You want to figure out exactly what that is, and then that's an important variable you need to use in your calculations later on. You can carry that on throughout your code. And we'll see more examples of that in the demo. So now advanced functions. So how do we make something more complicated? That before that was pretty simple. It's just like a 1 or 2 variable function, and it's like you could do like, I don't know, x squared or something. That's pretty simple. It's very elementary, I guess you would say. And a lot of times we want to make really complicated functions. I don't know, maybe something like this, kind of ugly looking equations where you might have like mass, radius, density, luminosity, temperature, all these different variables that you want to put in. You're definitely going to want to build more and more complicated functions. But to do that, also here's a couple more fluid equations. They're fun. You could do a lot more with those complicated equations. Say model the way fluids work, understand how luminosity leaves a star, etc. Lots of interesting functions that you'll come across in physics or astrophysics courses, and you might want to be able to code them. So how do you go about doing that? Well, you need one bit of information to understand that, and that's called variable scope. So outside functions. Oh, did I forget to record? Okay, no, I am still going. Okay, ooh, good. I almost forgot. Okay, sorry about that. Variable scope, sorry. So outside functions are global, variables that are outside of functions are global variables, and variables that are inside of functions are local variables. Now, what does that mean? So let's say I give you this example. I define a function called luminosity, where it calculates the luminosity of a star with a given radius and a given temperature. So radius and temperature are your input variables, or your arguments into your luminosity function. And what are the global and local variables here? Well, global is defined outside of a function. So what's considered inside of the function? Anything that's tabbed over, basically, inside of this def statement. So this is the head, and this is the return statement down here. Sorry, this bar is showing. But everything in here is the body. This is inside of a function. So inside of the function are local variables. So sigma SB, I define it to be some number. That's going to be a local variable. What about temp? Oh, well, I see temp is part of my input argument, but it's only valuable in here. It's only used in here. So that is a local variable. Sigma SB is a local variable. Radius is also a local variable, but pi is not a local variable. And that's because it's defined outside of the function. This is what we consider a global variable. I define it way up somewhere else outside of any functions, and this global variable can be accessed anywhere. It can be accessed both inside of a function and outside of a function, hence the word global. It's valuable everywhere. A good analogy I like to think of is like an inside joke in your house, or jokes or references in and out of houses. So let's say you're a family and you are in a house and you have like an inside joke with your parents that nobody else outside of your house knows, but just you and your family know. Well, that joke, that reference, consider that a variable. Nobody, that doesn't mean anything to anybody outside of your house. But inside of your house, it means something. It's got context to it. You know what that means. But say, for example, some common knowledge outside of your house, like what does a stop sign mean? Everybody knows what a stop sign means, whether regardless of if you're inside of your house or outside of your house, in any other house, doesn't matter. That like reference to that common knowledge, you consider that like a global variable. And the like inside joke would be of like your house specifically would be like a local variable for your house. But that's the way I like to think about it. Is there any questions about that variable scope right here? This is very important. Okay, I'll take that as a no. So, okay, I guess it's demo time. Let's go ahead and get into some fun demos. I'm going to start from the ground up. So let me move this over here really quick. Move this over here and this over here. And we'll do a new share. I'm going to start on my desktop. Can everybody see the desktop? Okay, cool. So I'm going to kind of walk you through how to get to your Jupyter notebook or something similar to it, and how to start a new file, and then we'll go ahead and do some demos on it. So first, let's go ahead and open up a terminal. So there's one way of doing it, which is doing like command space or control space, depending on what you're on, and typing in terminal, which is fun. That'll open up a terminal, but I kind of already have one open, so I'm going to open a new one down here with this terminal icon. It's like a little black box. I'm going to do new window. So I open up a terminal here. And right now, if we go ahead and print working directory to see where we're at, you'll see I'm under users, James Sunseri. So very like at the very top directory, there is nothing above it other than like the users, but there's no point in going there. So if I want to access things below or like inside of the James Sunseri directory or folder, well, I got to see what's inside of it. First, let's do ls. I see all my different folders. These are kind of like the main folders of your computer: desktop, documents, downloads, pictures, you name it, a whole bunch of good stuff there. So I'm going to go into my desktop because that's where all my files are. So let's go ahead and desktop. So I changed my directory into my desktop. If I go ahead and ls, you'll see basically all of these files and whatnot here. So C10, that's a folder right here. Code projects, that's a folder right here, and so on. There's all these different folders and they're listed here with some miscellaneous files. I'm going to ahead and go change my directory into the Python decal, just like so. So now I'm inside. Now I'm basically inside of this folder, and just for proof, I'll go ahead and open up what it looks like visually just by double clicking on it. You might be wondering, like, why would I ever care about doing this? This seems really tedious when I can just double click. It becomes very, very useful when you can't really see it visually on your computer, and there are cases when that does happen. Also, it becomes really quickly when you're good at typing. So now I'm inside of this folder. I'm going ahead and let's go ahead and I'll cd into demos. So now I'm in the demos folder, and I'm going to actually I'll go back. Just so another reference, cd ... means go out of directory or go backwards a directory. So pretend that basically I just undid what I just did, and I'm going to type in Jupyter Notebook. So I want to be able to access everything. So go ahead and make it. Go ahead and open up a Jupyter Notebook, and you'll see it opened up a thing on Safari. There we go. So now this is kind of like your Jupyter Notebook interface. Can everybody see the Safari window? Cool. So now I'm like in that folder. I'm going to go ahead and click on demos, and then I'm going to make a new Jupyter Notebook. And like in the case of your homework, you'll download like an IPYNB file. It looks like .ipynb. It'll say homework 1. You'll put it in whatever directory you're gonna be wanting to work in. I suggest making like a Python decal folder, and then you can just plop it in there with like your graphical. You can just move it in there with your mouse. and then go ahead and do this whole process, and you'll see it right here. And you'll know it's a Jupyter notebook when it has a little book next to it. That's when you know it's like a notebook file that you can work in, and you do all your work on the file. But in this case, I'm going to make a new one. I'm going to make a new Python 3 notebook. This is basically just a notebook that tells me I have Python in it. It's using Python. So let's go ahead and get started. Is it possible to zoom in? Yes. Is that better? Can everybody see that? Sorry, that might have been a little late. Hopefully that's a little clear. This is the name. This is the name of your file. So let's just go ahead and name it demo underscore today. Whatever, doesn't matter. We talked about the basics of the current or of the notebook, so I'm not going to go too much into it right now. So let's go ahead and get into the demo. So let's show the basic Python functions and how you use them. So let's say I want to print a word out to the screen. So, or like a sentence. Let's say, I love coding so much. Okay. So if I shift enter or run this little run button is the same thing as doing shift enter. It's like a shortcut. You'll find it's much faster just to shift enter, but I'll run just right now. So if I run that cell, it tells me I love coding so much. And I can do lots of other things. I can print, I don't just have to do strings. I could do like just a number and it'll give me like 7. It'll just print the number back to me. And if I were to, you know, see like what type of or like thing it spits out at me, you might be a little surprised to say that it says none type. That's because the print function returns nothing. It just, all it does is take whatever you give it and copy it and like basically repeat it to you, but it doesn't return anything to you. Like how we said return a value, it returns something called a none, which is just a none. It doesn't return anything to you other than none. But that's a type of built-in function. Print is a built-in function. You could do like, we can make a list of numbers. So let's just, we'll call it nums, and we'll make a list, say 1, 2, 3, 4, 5, 6, 7, -2, -4. So we have this list of numbers. Let's say, call that nums, just run that. And then I want to find the max of this list. So I just use the max function. I just put the max of nums, and it'll give me 7. So that's the maximum. If I write the min of nums, what's that going to give me? That's going to give me -4 because it's including the absolute, or not the absolute, like the negative to it. It includes the negative numbers. And then absolute value of say -10. It's pretty straightforward. You get 10. So those are Python's built-in functions. They're very basic, but it's important to know how to call them. You write the name of the function, parentheses, your argument, and it'll spit out a value. And if you wanted to, you could say, you could set like that value equal to a variable. So now I can say print x if I wanted to, and it would give me the same thing where x becomes the absolute value of -10, and you can print that value. And then now let's go ahead and get into actually defining functions. So let's say you wanted to explicitly write out how to square a function. So let's go ahead and make our own function called square. So I'm going to define it, have our word def. I'm going to define it with the word square. That's the name of my function. And then it takes in just any number. So I'm going to call that x, just like a normal f of x would. And then I'm going to make my body. So we're going to say y is equal to x squared. Remember, the double asterisk means squared, or to the power of, and then we just use the 2. And then we end it with a return value. So this is going to be returning y. Cool. And so if I wanted to, I can call square on, say, 10, and it'll give me 100. Easy, fair enough. You make your own function. You can write whatever you want. You can make really, really complicated functions. You could put functions inside of functions, inside of other functions, and call them all sorts of business like that. That's not really important. If you want to like learn the ins and outs of how functions works, I recommend taking Sp21. But for our purposes, that's just a basic function. And we can make it a little bit more complicated. We can define like a global variable, right? So we'll say pi is equal to 3.14. Okay, and then so that's a global variable. It's not inside of any function. And then let's say we want to calculate the surface area of a sphere. So I'm going to write a function called surface area where it takes in a radius r. And in this function, we'll say that the area, this is the body of the function, is 4 times pi times r squared. And then we could return a. Remember, notice how these are all indented by a tab inside of the function, not a space, but a tab. And then here is just a bunch of spaces, but you have to keep everything that's inside of the function tabbed inside of the function. Anyway, so that gives us our surface area function. And just calling this right now doesn't do anything because I'm not calling the function, or I mean, running the cell doesn't do anything because I'm not calling the function yet. So if I called it at the end right here, surface area of a sphere with radius 2, well, it's going to tell me that this is 50.24 or whatever arbitrary units you're using. I'll say meters, whatever, squared. And then it's always good to comment your code. So if you want to write a comment, which is just basically a statement about what, or saying what your code is doing without actually including it in the code and making it mess anything up, you use $, or like a pound sign or like a hashtag. And then you write weird over your statement. So this is a comment telling you telling the units are m squared, for example. And if I run this, nothing happened, nothing changes. It's just literally a comment to tell the user or whoever's reading your code what this is doing. So that's a comment. This is a surface area function, all good. And then my last example of like writing your own function that you might want to use. Let's say you wanted to convert from Celsius to Fahrenheit. That would be a pretty useful function. Or I guess we'll do def convert temp. That's what we'll call it. It'll be the name of my function. It's always good to make sure that your function is like a pretty reasonable name. You don't want to just name it A and then like not know what it's doing, you know, especially if you're doing really complicated functions. It's good to spell out what that function kind of does. I mean, don't be overly explicit, but you know, notice how for a squaring function, I use the word square. Surface area, it's pretty straightforward. I just make sure that whoever's reading my code can actually understand. So, you know, use descriptive variables or variables that are pretty obvious, like R is obviously radius for the surface area, T is obvious for temperature, and so on. But for more complicated functions, you're going to want, you know, to be a little bit more explicit. Anyway, so let's say that the temperature is equal to, how do you convert to Celsius? What is it, like 9/5? That's 32? Yeah. So I'm going to say whatever temperature I put into my function in Celsius, I want to turn it to Fahrenheit. This is the equation for it. And then you can just return temp. And what this does is, you know, if I call it now and I give it, you know, temperature of, I don't know, 48 degrees or 49 degrees Celsius, it'll give it to me 120.2 degrees Fahrenheit. Pretty hot. So those are basic uses of a function. A couple others that might be really useful. You don't just have to use numbers all the time. You can actually use words or like strings and letters and all sorts of other data types. So just to give you an example of a function that takes in a string. Let's say I'm going to create a function called flip, which basically takes it in a word and it flips it. So you might be curious on how you might go about doing that. So I'm going to call a flipped variable. So whatever this is flipped is equal to is going to be like the flipped word itself. So what do? Well, we say whatever that word is, right? We're assuming that it is a string. So it behaves like a string. And we talked a little bit about how you index into strings on Monday. Use a little syntax with like square bracket notation, right? And then so in this case, this is, we talk about this in your homework a little bit more, so don't worry about it too much. But basically this double colon and -1 just tells the computer, hey, take this string, take all the values in the string, and then just flip them with the -1. That's what this means. More on this is in your homework and on the guide that we're going to give you guys. I'm going to upload that as soon as lecture is done to help you with your homework. So anyway, returning this, we get on time. Yeah, we got time. Go ahead and do this, and we can return that body of our function, the flipped variable. And if we run this right now, nothing's gonna pop up yet, but if we go ahead and feed it a word, we'll call it, I don't know, Raphael. It should give you Leaper or Leaper. And something that might be kind of fun, give it a palindrome like race car. Ooh, I can't spell. There you go. Who's race car? Ooh, fun. And one more example of multiple variables. All these have been single variables. Let's go ahead and just write that really quick. If you want to have multiple variables in a function, say like a quadratic function, well, let's give it A, B, and C for generality, and then it definitely has to take in an X value, right? So it's defined for any X. And you just go ahead and write it like how you normally would, just with the weird Python syntax. So I'm going to say Y is equal to A times X squared plus B times X plus C. Yeah, and then we just go ahead and return Y. Cool. And then if I call this, now I have a quadratic function that'll, for any given set of like general parameters, you can give it whatever, or it'll return whatever X value corresponds to that quadratic function. So for X is 9, with those A, B, and C, you get 103. Super enlightening. I know, it's super awesome. I have one really cool demo at the end, but I want to make sure that I kind of show you a little bit more on so you can understand it. So stick around. Am I good on time? Oh yeah, I got 10 minutes. Okay, so I want to talk a little bit about import statements. They're pretty useful. We'll get way more into this when we talk about like NumPy and other things, but the way Python is designed, it's basically like a glorified calculator with a little bit of extra stuff, or with a lot of extra stuff, but there's a lot more useful things you can do with Python if you use packages that people have already pre-coded for you. Say, for example, the math package. So this math package that you can import into Python allows you to do tons of math. All I was doing, like multiplied, squared, divide, that's great and all, but what if I wanted to calculate the sine or a cosine? You can't just do that right out the gate. You can't just say sine of X. Python doesn't know what that means. Or sine of 3. See, we don't have like a sine function just ready to go. So how would I go ahead and do that without having to literally code the sine function itself? Like, that sounds kind of complicated. Well, you do something called import math. And what this does is it imports the math library so that everything inside the math library is at your disposal. Well, you might wonder what's inside of the math library. Well, let's just go ahead and check. So if you write help, this is a built-in function, the help function. Whatever you put inside of it, it'll tell you about what that what that variable or what that name is in the code. So now that we imported math, this is everything inside of the math library. So zoom out a little bit better so everybody can see. These are all the functions available to us: arc, cosine, cosine, degrees, exponentials. If you want to do e to the power of something, gamma functions. It gets a lot more complicated. Log functions, radians, converted radians, arctangents, hyperbolic tangents, etc. Different values. So if you wanted like a really accurate value of pi, now you have it. And the way you use anything inside of the math library is you kind of do it like this. You do math dot whatever the function is. So math dot cosine of 1, for example, should give you the value of cosine. Since I imported the entire math library, I can also just use the names of the functions inside of it. So I can just do cosine of 1 instead too. Oh, I guess not. Never mind. Oh, never mind. Apologies. I did not mean that. There's other ways to import statements. I just got them confused. But yeah, so the way you access anything from the math library is you do math.cosine. What I like to do is say import like whatever my library as whatever I like to call it. So I call it the M. I just call it M for short, so I don't have to write math every time. So now if I do that, instead of math.cosine, which does work, I could just use m.cosine and it gives you the same thing, or m.sine. And that way it's just a lot shorter for you. Because if you have to do, let's say you have some crazy library that's like literally like 25 characters long, that's a pain in the butt in every single line that you need it. So that's like an important tool. But anyway, so that's just basics of import statements. And with that, I want to show you a little code I made for everybody. So I'm going to do another import statement. And also good practice is usually to put your import statements up at the very, very top in your first cell, but it's not important. I'll show you that in the homework and stuff later. So now let's go ahead and do some fun stuff. So import system, I believe is what I called it. Oh, my bad. This is just another way of doing it. You could just say from whatever library, import a particular part of that library. So I'm just importing system. Don't worry, it's the same. It's the same thing. It's doing the exact same thing as the import statement, just written a little funny. I'm just importing a specific kind of like function. We call system is a function inside of the OS library. So I'm importing that function itself. Cool. And what this is doing is basically just making it so that I can use a function that like does like hard code outside of the Python, but don't worry about it. That's not important. What is important is that I'm importing a library and I'm using a function from the library. And I can make an even more complicated function. So let's go ahead and run that import statement. And now I'm going to make a cool function. So we'll call this play Mario. And my Mario function not all functions need to take in arguments. Some don't need arguments at all. And this function is one of them. I mean, I could make it take in arguments if I wanted to, but that's not always the case. Some functions don't take anything in, they just kind of do something. And that really depends on you, the coder, and how you want to implement your functions and whatnot. Others definitely need arguments, but in this case, this function does not. It's not always needed. So I'm going to say command, CMD, short for command. I'm going to write a string where, I'll write it like this. I'm going to just write like this is just a string, but it's basically a command for my computer to take in. Okay. And with this command, I'm going to call the system function that I imported above. This is like a global name, right? It's called outside of the function, so it's usable for any function if you wanted. And this is like a local name or variable, however you want to call it. But this is the system function from the OS library that I imported. And in doing this, let's go ahead and call the system function on my command that I just wrote. And really quickly, let me make sure I'm sharing my sound. Yeah. So, and then if I just, and then with this function, I don't want it to return anything in particular. So I'm just going to do return none. So this is not going to return anything that I can like put in another variable. It's literally just going to do something. It's going to take in nothing, and it's going to give out nothing, but it is going to do something while it's running. And you'll see exactly what I mean by that. So I'm going to call play Mario right now, and I believe everybody should be able to hear this. Everybody hear that? Yeah, it's a little longer than it needs to be. But anyway, you get the point. So all I did was just use a bunch of stuff that I just taught you today. I made an import statement. I literally just imported a function that somebody has already written. I don't need to know how they wrote it, but I just imported it. And I just used it to my benefit, just like I would use like a cosine function from a math library. I use a system function. You don't need to know what that does. It's a little bit more advanced. But anyway, I use that function and I define a more complicated function that uses a function inside of a function. So I call that, like I just did my normal header define statement where I say play Mario is the name of my function. It takes in no arguments. Don't forget the colon. I do my body of my function where I write a string that is going to be the command that I put into my system function, and it doesn't return anything. But what it does do is it executes the function, and it given that function's argument, which is just a string, and it does something kind of cool. So I thought that was kind of fun. I hope that was useful. We're 1 minute shy. If there's any questions, I'm happy to take them from anybody. But yeah, that's it for today. Your homework 1 is available. If you would like me to show how to put it in, like, on your computer and open it up, I'd be more than happy to. But if nobody has any questions, then you're free to go.
What time is the homework due? I think you said it's due next Wednesday.
It's due right before lecture. It's due before next week's Wednesday lecture. So you have an entire week to do it, and it'll be due right before Wednesday's lecture.
Okay, so we can say like 5 o'clock on Wednesday.
Yeah, 5 o'clock on Wednesday.
Cool. Perfect. Thank you.
I'm going to put a link to the Discord in the chat so people can join.
Sorry, what'd you say?
I'm going to put a link to the Discord in the chat so people can join if they would like to.
Okay, so everybody join Asher's.
Yeah, join Asher's.
Okay.
One second.
Where, Asher, can you put it in the...
I got it. I was just copying it.
Okay, cool.
That should work. And if the instructors want to join so they can answer questions, just let me know what your username is so I can give you the instructor role.
Okay. Yeah. I'll do that. I'll send you an email, Asher.
All right. Thank you.
Cool. Thank you. Yeah. And if anybody has any questions about how to open up the homework, I can stick around and help you with that. But if you feel like you got it, then go ahead and you're fine. You can head out if you want. Thank you, everybody, for coming, by the way.
Thank you.
Thank you.
For the homework, we basically just add the file, right? I think I did it earlier.
Yeah, you just download it and then put it in a directory that you know where to access it. So I recommend making a Python DeCal folder on your desktop and putting it in there, and then that way you can just go in there, run the Jupyter Notebook command, open it up, and you know exactly where your file is.
Okay, that was my question. So to make a file, I just make it on my desktop and it'll show up there.
Yeah, so make a folder. I would make a folder on your desktop and then put just go ahead and how you would just move a normal file around.
Right.
It literally just think of it as like a text file that's complicated. So just move a text file around.
Okay, cool. Thank you. Have a good week.
Cool. I guess I can stop recording right now.